Okay, this is the third video of our basic statistics. We're going to look at measures of dispersion and something called a box and whisker, 5-number summary, and a box and whisker diagram. Let's just get started. Well, measures of dispersion tell us how spread out the data is. One thing that's good is the range itself from the biggest piece of data minus the smallest piece of data. Well, that gives you the range. Quartiles divide the data into 4 equal portions. 1/4, so we sometimes would call it the 25th percentile. It's the first quartile. And then there's the third quartile. And then there's the median, which is the second quartile. And the maximum, I guess it's the fourth quarter. I think there's a little bit of a title. The lower quartile is the first quartile, and the upper quartile is the third quartile. A little bit of a misprint there. How do we figure out where the lower quartile is? Well, all we do is we take the number of pieces of data, add 1, divide by 4, and we'll get a number that tells us the position. If we take the number of pieces of data we add 1 and multiply it by 3/4. Take 3/4 of that number, we'll get the position of the upper quartile. Okay. Now, let's take a look at this. There's something called the interquartile range, and that's just the third quartile minus the first quartile. And the semi-interquartile range, they can sometimes put those words in there. It's just that quartile range divided by 2. Well, what's a box and whisker diagram? Well, all you do is you spread this data out, the minimum, the second quartile, the second quartile or medium, the third quartile and maximum. You just put it on a number line with a box between the first and the third quartile. And you just make a scale like so, and you put the 5 numbers right here. You put your minimum somewhere, so this would look like a minimum of whatever, like 5. That looks like a max of 62, and you just put the numbers like that, and you make a box that shows the 50% of the data in the middle. Between the first and second quartile, there's 1/4 of the data. It really shows you how it's spread out, Okay, let's take a look at some of this data here. Now, you've got the heights of 20 children. They've been kind to us and put it all in order in centimeters from 127 all the way up to the tallest person that's 145. Now, let's take a look at this. We can figure out all these different things, like how would we figure out where the first, well, there's the minimum, 127. There's the maximum, 145. Okay, now how do we find the first quartile? Well, all we do is take 20, add 1 to it, divide by 4, and we get 5,25. Well, that means that your first quartile is in between the 5th and the 6th piece of data. And all you do is find an average. Go 131 plus 133, divide by 2, 132 is where your first quartile is. Now the median, where's the median? Well, that's n1 plus 1 divided by 2. It's 15. The median is 21 divided by 2, 10.5. That's right in between 10, the 10th term, and the 11th term. So 136 plus 137 divided by 2, the median to calculate, here's the medians calculated here. The median would be 136.5. You just add those 2 and divide by 2. Let's take a look at the third quartile. Let you do that thing again. 26 plus 1 times 3/4, you get 15.75. Well, that's between the 15th term and the 16th term. Then you just add them, divide by 2. That's why the third quartile is 141.5. Well, there's all our numbers. That's it. Minimum, first quartile, medium, third quartile, and the maximum. Now, what do we do to make a box and whisker graph? all we do is put them on a number line. It starts at 127. It goes all the way to 145. 141.5, just right about pretty close, right close to there. 136.5, pretty close to there. 132, pretty close to there. Make a box around the first and the third quartile. Put a line right through the median, and there you have it, your box and whisker graph. Now this tells you how the data is sort of spread out. This is a little bit fatter on the right than it is here, although it's pretty evenly distributed. We could say it's skewed slightly to the right here. Now, if you have this box way going out here and this being a skinny part, we'd say it's skewed to the right. And if this box here is much bigger, or it's bigger, we'd say it's skewed to the left. And that's I'm going to go right to the end to talk about these measures of distribution of data. This would be data. See when it's right in the middle and the box is pretty the same on either side? We say, well, they could actually call this a normal distribution. It's symmetrical. It's evenly distributed. But what if the box is way bigger on the right? Well, if it was a bar graph, it might look a little bit like that. We say the data is skewed to the right. So whenever they ask about how is it distributed, you can talk about this being skewed to the right. And here's 25% of the data that covers a great, a long spread of numbers here. That 25%, we'd say it's skewed to the left. And that's what it would look like if you were looking at it as a bar graph, something like that. So that's how we talk about these distributions. Oh, I hope that helps.